Welcome to another episode of Ask Better Questions. In today's episode, we'll be delving deeper into neural networks, and we'll also be taking a longer look at why organizations should take note of AI. Now, before we get into the episode, I'd like to take a moment to thank our sponsor, Color4 Solutions. I'm a director at Color4 Solutions, and we provide independent advice on AI implementations for business looking to automate any business function. So if you're in the market to automate or implement AI in any of your business processes, be sure to reach out. Links are in the description. So what's a neural network? So neural networks, ANNs, so artificial neural networks or simulated neural networks, SNNs, are types of machine learning algorithms that excel at recognizing patterns and making predictions from data. So neural networks have become increasingly prominent in recent years due to their remarkable performance in various applications, including image recognition, natural language processing, and machine translation. So neural networks are composed of interconnected nodes or neurons arranged in layers. Now these neurons receive input data, process it according to their activation function, and transmit the processed information to the next layer, and so on and so forth. The connections between these neurons represented by weights, which determine the strength of the signal transmitted from one neuron to the next, basically. Now, there are various types of neural networks, four main types. Feed-forward neural networks. Now, these networks have unidirectional flow, so they go one direction. So they have directional flow of information from the input layer to the output layer, and that's the one direction. They're widely used for classification and regression tasks. Now, recurrent neural networks, or RNNs, are designed to process sequential data such as text or time series by incorporating feedback loops that allow information to persist across time steps. Convolutional, I always get that wrong, convolutional neural networks, or CNNs, are particularly effective for image recognition and analysis due to their ability to extract spatial features from images. So a lot of CCTV, facial recognition systems are CNNs. Autoencoders. Autoencoders are neural networks that learn to compress and reconstruct input data, enabling them to identify and extract important features. There is a training and learning process. So with neural networks, you can't talk about neural networks without also talking about how they're trained and what they learn, in what ways they learn. So neural networks are trained using a process called supervised learning. Predominantly, they can do unsupervised, where they are presented with labeled data and learn to associate input patterns with the corresponding outputs. So basically, put in an input, wait for it to spit out an output, figure out whether or not you got the desired output that you wanted based on that input, and then adjust the weightings in the various layers in between and see whether you move closer or further away from the stated output that you want. And this is done however many times you need to get the desired outcomes. So basically, the training process involves adjusting weights for the connections between the neurons, minimize the error to rates, etc. And then you'll get an actual label that's predictive. Now, this optimization is often achieved using an algorithm called backpropagation. So taking what the output was and backpropagating it back. Neural networks have done a lot of work. They've revolutionized various fields. Computer vision. Neural networks excel at image and video recognition, enabling applications like facial recognition for obvious, mentioned earlier, CNNs. But they've also done a lot of work in autonomous vehicles, object detection, things like that. Natural language processing, obviously ChatGPT and various other GPTs utilize neural networks, and they power machine translation systems, chatbots, sentiment analysis tools, things like that. There's also speech recognition. Neural networks have significantly improved the accuracy of speech recognition systems, enabling voice assistants and dictation software. So when you're saying, Alexa, do XYZ, or any of your other automated services. A lot of that's driven by neural networks now. And of course, predictive analysis. Neural networks are used to predict customer behavior, market trends, assess risk assessments, and assess risk in finance and healthcare, obviously. So there are future directions, but there are also challenges. So despite remarkable achievements with neural networks, there are problems with interpretability. So neural networks can be difficult to interpret. So oftentimes you'll put in an input, get an output, and go, why? What is that? And not only what is that, but how did we get to that? It can be challenging to understand the reasoning behind their decisions without being able to flip the hood. And a lot of these systems are closed black boxes. There's also data dependency. Neural networks rely heavily on large amounts of training data, which can be expensive and time-consuming to get. Computational complexity. Training large neural networks can be computationally expensive, requiring specialized hardware and algorithms. Now, researchers are actively addressing those challenges that I've just mentioned, exploring new directions for neural networks, including explainable AI, or XAI, which is developing techniques to make neural networks more transparent and explainable. Federated learning, which is enabling collaborative training of neural networks on distributed data without compromising privacy. And neuromorphic computing, which is creating hardware architectures that mimic the energy efficiency and parallel processing capabilities of the human brain. That is more niche, but it's still under the setting of future direction. But basically, neural networks have emerged as a transformative force in artificial intelligence. They really have brought artificial intelligence to the fore in most people's minds. They've enabled groundbreaking advancements in research, and as the research into neural networks and corresponding computational power increases, neural networks are poised to play an even more significant role in shaping the future of technology and artificial intelligence. So that brings me to the second half of this episode. What's the future of AI, and how will it impact you, me, culture at large, businesses, organizations, those sorts of things? I guess what we really need to do is we need to start with AI adoption. Okay, so AI has been adopted at an unprecedented rate. Compared to other technologies, it took 40 years, and I use US data here because US data was easiest to get to. It took 40 years for electricity to reach 25% of US households. Now that's 1/4 of US households, not all of them, 1/4. And whilst the internet reached that milestone in just 7 years, AI is on track to reach that 25% adoption rate within 8 years. Now that makes it one of the fastest adopted technologies in history. Not the fastest, but right up there. Now there are several factors that have contributed to the rapid adoption of AI. Look, firstly, AI has become increasingly powerful and capable in recent years. This is due in part to advances in computing power, as well as developments of new algorithms and techniques. And secondly, AI has become more accessible and affordable, with cloud-based AI platforms making it easy for businesses and individuals to get started. And finally, there's a growing demand for AI solutions as businesses and organizations across all industries are looking to use AI to improve their productivity, efficiency, and decision-making. So going back to that adoption rate, electricity again took 40 years to reach a 25% adoption rate. Now, the telephone took 35 years, so almost as long. Radio took 22 years, television took 21 years. The personal computer took 13 years. So, as I said, internet 7 years, and AI is estimated to do it in about 8. Now, it could be less, it could be more. But if we think about what AI is in pure economic terms, we discover something really interesting. So electricity, what's that? Well, electricity allows us to use lights and extends our day, improving overall productivity. The phone allowed national and international communications, shortening the distance between people and allowing for communications over vast distances in immediate terms. Radio and television expanded our worlds, allowing us, mass media and entertainment industries. I guess, like, not just entertainment industries, but a much larger entertainment industry. Films and the like would not be possible without radio and television. The personal computer allowed us to leverage productivity, although I have to admit, I've had it explained previously that one of IT professionals told me once in the 90s that setting a PC on every desk was like giving everyone a bicycle. Easy to do, but pointless for those that can't ride. If you give everyone a PC, you must teach them how to use it, or it's kind of just a very, very expensive paperweight. Now, the internet leveraged communications globally and allowed anyone connected to share thoughts and ideas with anyone else that was also connected. Now, the importance of that technology in the modern world cannot be understated. And the easiest way to explain that might be to ask how many people would leave their home in this day and age without their mobile phone. And the answer is not many, as that is our link to the rest of the world, to banking, communications, gaming, and even for some of us, the key to our cars. There are so many applications for mobile phones. Now, mobile phone technology is built on, GSM and 5G now and the like. But at the same time, a lot of what's in our phones is built with the internet in mind. And it's our link to the internet, which is our link to everything else. So what does AI bring to the table? Well, I postulate to you that AI is the ability to outsource thought, right? The ability to outsource thought. So what does that even mean? Well, warning, a quick economics lesson incoming. But if goods and services are created with capital and human labor, then capital is the physical machinery, land, buildings, that sort of thing. And human capital is the worker showing up to use that equipment and also create the systems to use that equipment. So, like, we're going to plow this field with that tractor. Okay, cool. What are we going to plant? Well, we're going to do this, and then we're going to rotate these crops this way, etc. That's all human capital, but the actual equipment they're driving and the seeds and the like is physical capital. So AI then represents the ability of humans to engage. Well, humans now have the ability to engage AI to remove the necessity for much of that human input in that equation. So creating the systems, running the machinery, determining what orders to place for materials, placing those orders, these tasks can and are already being automated. So what does that mean, in terms of, so what? Okay, well, companies and organizations of all natures, private sector or government, exist to create and provide goods and services, right? So one of the biggest costs of doing that is labor. So much of that, in many large organizations, so much of the labor costs drove organizations to outsource their customer service to large call centers in locations where labor costs are lower. They shift manufacturing where it's cheaper to do so. Now, often that's driven by labor costs. Large factories will employ heavy machinery as it's both faster and cheaper to operate due to low labor overheads. So in the 20th century, there was the 20th century was a case study in using machines to remove physical labor or reduce its impact on businesses. Consequently, many of us were employed in roles pushing pencils in offices or writing desks. The bicycle example above notwithstanding. The 21st century will be a similar study in reducing the thought capital required in organizations. So how does that play out? What does that look like? Well, we're going to see a great number of low-level and entry jobs disappear. Now, for some, that's a reason to panic. And for others, it will present a huge opportunity. Effectively, I suppose to put it in historical terms that we can all understand, the vast majority of people used to work on farms. And now we produce much more food than we ever have, and we have far fewer people working on farms. And that's not a problem. Nobody goes, we should get more people into farms. We haven't removed people entirely from farms, but what we have done is increase their productivity to a point that we don't need as many people to work farms. and that's a net benefit. We've seen consequently, a shift from an agricultural to an industrial age, and now from an industrial to a technological age, and that is going to continue and accelerate because of AI. We saw a huge shift to cities and factories, but now fewer and fewer people are engaged in factory work. Each employee is far more productive by and large, and most modern economies have shifted towards services. Now, the scary implications are, with AI, many services jobs can be automated away. Now, is this a bad thing? Well, it may be good in some areas and probably less good in others, but just because you can put a jukebox in a bar doesn't mean that you don't have live bands, all right? Just because you can get a robotic chair massage doesn't mean that we don't have human masseuses, all right? But there's still a place for direction of AI, and many new jobs will be created in that space. Now, do we really need a whole bunch of people doing data entry when you can have AI do that? Well, ideally no, because those sorts of jobs are the jobs that we probably want to do away with. But at the same time, that's not a decision for myself, that's a decision for the business to decide whether it's worth engaging AI to do that. And having done a lot of work in that particular space, AI is a much cheaper option and a better option than having rooms and rooms of people punching numbers into a computer. So with that direction in place, a lot of new AI jobs will be created, and much of exactly how that plays out will be solidified, and a lot of that will be determined by regulation, and that is yet to be hardened and discovered yet, so or even announced. It's not all doom and gloom, AI providing the ability for businesses to utilize low-cost thought via AI will magnify productivity and change the composition and the ways in which we work in a similar way to the Industrial Revolution. Now, what's that going to look like? Well, the 9-to-5 workday may be a thing of the past. 5-day work week may also go the way of the dodo. People will work when they need to work, and AIs will work almost constantly. So it's for that reason business owners, and in fact all of us, should be watching the developments within AI with keen interest. So that about wraps it up for this episode. If you're interested in what AI can do for you and your business, please reach out via the links in the description. If you like the podcast, leave a rating and review and subscribe so you don't miss an episode. I'm Peter Adams, and I'll be here next week to ask better questions.